Hi everyone, in this video I'm going to solve O-Levels Additional Mathematics Paper 1 in a session October-November 2023 Paper 1-3. So let's start with the first question. Question number 1 part A, on the axis sketch the graph of the linear function and absolute value function stating the intercepts with the coordinate axis. Okay, so we have to state the intercepts as well, right? So first let me start with this equation and finding the x and the y intercept of the equations, right? Let me solve it over here. So we have equation y equals to 2x plus 5, right? Now for x intercept, we have to put the variable y equals to 0 and solving for x. So 2x plus 5 would be equals to 0 and x should be equals to minus 5 by 2. Okay, and minus 5 by 2, this would be 2.5, negative of 2.5. So x-intercept is minus 2.5 and 0. Right. Now let me work on y-intercept. So x should be equals to 0. So y is equals to 2 times of 0 plus 5. So here y equals to 5. So the coordinates are 0 and 5. Right. Now for the other equation, the absolute value function for this, let me use y equals to absolute of 4x minus 5. Minus 3, not 5, sorry. 4x minus 3, yes. Okay, let me solve for x and y intercept for this as well. For x intercept, x is equals to 0. So sorry, y is equals to 0. So absolute of 4x minus 3 is equals to 0. So it means 4x is equals to positive of 3, shifting 3 on the other side. So x should be equals to 3 by 4. And in terms of decimal, 3 by 4 is 0.75. 0.75. So here the x-intercept is 0.75 and 0, right? Now for y-intercept, we have to put the variable x should be equals to 0. So y should be equals to, absolute of 4 times 0, negative 3. So y is equals to absolute of minus 3, which is positive 3. Y is equals to positive 3. So the coordinates of y-intercept are 0, 3, right? Okay, now let me sketch the graph for both functions on the grid. And we have to state the intercepts with the coordinate axis. All right. Okay. So the scale for x, we are using 1, 2, 3, and 4. 1, 2, 3, 4. And same for y. 1, 2, 3. 1, 2, and 3, right? For the first one, the linear equation y equals to 4x plus 5, the x-intercept is minus 2.5 and y-intercept is 5. So y-intercept is 5. Let's say this is 2, 4, and 6. So 5 is the y-intercept in the middle and 2.5, negative 2.5. So if I can say the x is 1, minus 2, minus 3. This is 1, 2, 3. And this is negative 2, negative 4, and negative 6, right? 2.5 is over here, right? So this would be the linear one, 5 and 2, negative 2.5. All right. Okay. The next absolute value function, the x-intercept is 0.75, closer to 1, and the y-intercept is positive 3 over here, right? Okay, the same thing we have to do on the other side. This is absolute function, so we can say, let me take another point. Let's say at x is equals to 2, what is the absolute value function? Y should be equals to 4 times 2 minus 3. 4 times 2 is 8. So y equals to absolute of 8 minus 3. So y should be equals to absolute of 5, which is 5. So add 2, it's 5. Okay, this is 2 and this is the point 5. So this is the next point. So the red one is the absolute value function and the green one is the linear function, right? Okay. Now for part B, solve the inequality, right? So we have to solve this, we can say this is plus minus 4x minus 3. To open the absolute, we will have plus minus less than 2x plus 5. Now in to get rid of this plus minus, let me do squaring on both sides. Okay, so we have 4x minus 3, its whole square. This is less than 2x plus 5, its whole square, right? So we have 4 square would be 16x square plus 9 minus 2ab. So minus 2 times 4 times 3, which is minus 24x. This is less than, we have 2 is 4x square, 5 square is 25, plus 2ab, 2 times 5, which is 20x. Right, now let me shift all the terms to the left side. So this should be 16x square minus 4x square minus 24x minus 20x and plus 9 and minus 25. This is less than 0, right? 16 take away 4 is 12x square. 24 and 20 is negative 44x. And 9 minus 25 is negative of 16. This is less than 0. Let me divide throughout the equation by 4. 12 by 4 is 3x square minus 11x, and 4 times 4 is 16. This is less than 0, right? Now let me factorize this. 3 times 4 is 12, and 1 times 12 is 12, and 1 minus 12 is negative of 11. 3x square minus plus x minus 12x and minus 4 is less than 0. Factorization, x is common, we are left with 3x plus 1, and negative 4 is common, 3x plus 1. This is less than 0, right? Now let me make the factors. This is 3x plus 1 and x minus 4. This is less than 0, right? So from here 3x plus 1, if I put it equals to 0, so x should be equals to minus 1 by 3 is the factor, and x minus 4 equals to 0, so here x should be equals to positive of 4, right? Now we have to select the inequality. So as you can see, we have a quadratic equation over here, right? And the leading coefficient is positive, right? So it should be a parabola, and the opening of parabola is upward, right? Okay. So let me visualize the situation. The opening of parabola should be upward, and we have two zeros, minus 1 by 3 and positive of 4. So this is minus 1 by 3 and this is equals to 4, right? Now we have to check the solution when this is less than 0. It's negative, between 1 by 3, negative 1 by 3 and positive 4. The inequality is satisfied. So we can say the solution is minus 1 by 3 is less than x is less than 4, right? Question number 2, the perpendicular bisector of the line joining the points passes through the point 2k, find the value of k, right? So first we have to find the perpendicular bisector of the line joining these 2 points. So we need the midpoint and we need the slope, right? So the first thing, we need the midpoint. Okay, so for midpoint, we have to add the x components and dividing by 2, and adding the y components and dividing by 2. So negative 3 and positive 6 and divided by 2, and 2 by 3 and 7 by 3. Adding 2 by 3 and negative 7 by 3 and divided by 2. We will get the midpoint, right? So this should be negative 3 positive 6 divided by 2. Negative 3 positive 6 divided by 2. Yes, sorry, it's 3 by 2. I double checked. Okay, 2 by 3 and add -7/3 and divide it by 2. This is -5/6. Right, this is the midpoint. Now the next thing we need is the gradient or the slope. y2 minus y1 over x2 minus x1. So this is y2 and this is y1. So y2 minus y1 over x2 minus x1. This should be 7/3 and 2/3. -7 divides 3 and minus 2/3. -3 over 6 plus 3 is 9 and -1/3 is the gradient, right? Now let me write down the equation. So equation of perpendicular bisector right, which is now the equation of perpendicular bisector of the line that join the 2 points is y minus y naught equals to -1/m into x minus x naught, and negative and reciprocal, this should be 3. So y and y naught is plus, this should be 5/6, this should be 3, and x minus 3/2. Right, so this passes through the point 2 and k. X is 2 and y is k, and we have to solve for k. When it passed through the point, so it satisfies that equation. So y is k plus 5/6 equals to 3 into 2 minus 3/2. All right, now let me simplify. K plus 5/6, this should be okay, so -3 divided by 2 and adding 2 and times by 3. This is 3/2, right? And subtract 5/6 is 2/3. So k is 3/2 minus 5/6. So this should be 2/3. This is the value of k. Now question number 3 on the axis, draw the graph of this function for axis between -360° to +360°, right? So let me plug this into the equation and solving for the y values, right? So when x is -360, so 2 sine, it's in degrees. Let me convert my calculator into degrees first, okay? 2 sine of -360 divides 3 and subtract 1. This is -2.7. This is -2 and -2.7 is closer to -3 y value. Now at -270 degrees, 270, this is -3, okay, and -180, this is -2.7 again, okay, at negative of 90, right, it's -2, okay, and at 0 it's -1, right, at positive of 90 it's 0, at 180 it's 0.7. So 0.7 is closer to 1. Okay, at 270 it's 1, and at 360 okay, 0.7, right. Let me connect all the points to get the curve. Okay, that's the sketch. Question number 4, the polynomial p of x is given by, where a and b are integer, p of x has a factor 2x plus 1 and p of x has a remainder -6 when divided by x plus 1, right? So it means if it has a factor, so it means p of -1/2 this should be equals to 0, and it has a remainder, so p of -1 should be equals to -6. Now for part A, find the values of A and B, right? So let me start this with p of -1/2. This should be equals to 0. Okay, so A and -1/2 whole cube plus b into -1/2 whole square plus 3 into -1/2 plus 2, this should be equals to 0, right? So A, and this is -1/8, plus B, this is 1/4. This is -3/2, and +2 equals to 0, right? Now for further simplification, we have -3/2 and add 2, this is 1/2, right? -1/8a plus 1/4b plus 1/2, this is equals to 0, right? Let me make the same denominator. So 8, 4 and 2, the common denominator is obviously 8, right? So we are multiplying throughout the equation, multiplying and multiplying by 8, yes. So the common denominator is 8, so this should be -a. 4 times 2 is 8, and 2 times 4 is 8. This is equals to 0, right? Or we can say -a plus 2b is equals to -4. That's my first equation, right? Now let's make the second equation. For second equation, we have to say p of -1 should be equals to -6. Okay, so a -1 cube plus b -1 square plus 3 into -1 plus 2, this is equals to -6. So that's -a, +b, -3, +2, and -6. So -a plus b, this should be equals to, we have -6, -2, and +3. So -5, that is my second equation, right? Now we have two equations in variable a and b, so -a and -a. So let me subtract equation 1 and equation 2, right? Subtract equation 1 and equation 2. Okay, so we have -a plus 2b is equals to -4, and -a plus b is equals to -5, right? So now let me subtract the two equations. Subtraction means we have to change the signs basically. So this changes to positive, negative, and positive, right? So -a and +a is cancelled. Minus b and b, this should be b, and this is equals to 1, right? We got the b value, which is 1. Now let me substitute the b value over here in solving for a. So to get the a value, we have -a should be equals to -5 and -b. So a is equals to 5 plus b. So a should be equals to 5 plus 1, that is equals to 6. So a is 6 and b is 1, right? Now moving to part B, show that the equation p of x equals to 0 has exactly one real root, right? So let me write down the polynomial row. Okay, p of x is ax cube, which is 6x cube, plus bx square, which is x square, plus 3x plus 2 equals to 0, right? So let me solve for the roots, because we have given in part A that p of x has a factor 2x plus 1. So let me use a method of synthetic division over here. We have given the first factor. Okay. All right. So let me write down the coefficients here. So x cube coefficient, x square coefficient, x coefficient, and the constant term. The factor is -1/2. So let me bring the first term 6 down. -1/2 times by 6, 2 times 3 is 6, -3. Add it, so it's -2. So now it's 1, and this should be 4, and this should be -2, and it's 0, right? Now we have the polynomial now, which is x minus 1 by 2 is the factor, and the rest of the terms are 6x square. This is a quadratic one, and these are the coefficients, and minus 2 is a coefficient of x, and 4 is a constant term. This should be equals to 0, right? Now let me find out the factors for this. So first let me simplify this. So x minus 1 by 2, and this is taking 2 common, 3x square minus x plus 2, this is equals to 0, right? And now multiply the 2 over here, so this should be 2x minus 1 and 3x square minus x plus 2 equals to 0, right? So it has two factors, 2x minus 1 equals to 0, so x should be equals to 1 by 2. This is the only real factor, the real root, and the other root is 3x square minus x plus 2 equals to 0. Now let me factorize this and find out the roots, whether it is real or complex, right? Okay, so the factorization is hard, so let me use quadratic formula over here, right? So x should be equals to negative of b plus minus square root b square minus 4 times the a and the c, and divided by 2 times of a, right? So here we have x with is 1 plus minus square root, let me simplify, minus 4 times 3 times 2 and add 1, this is minus 23, divided by 2 times 3 6, right? So the square root involves a negative sign. So when it has a negative sign, it involves iota. So these are the two complex roots. So we can say the only real root is 1 by 2. So it is proof that the polynomial p of x equals to 0 has only one real root. Question number 5, part A. A 5-character password is to be formed using from the following 10 characters. So it should be a 5-character password. We have letters and symbols. 1, 2, 3, 4, 5, 6 letters and 4 symbols, right? No character can be used more than once in any 5-character password. So no repetition means it involves permutation. Number 1, find the number of passwords that can be formed. It should be 5. So 1, 2, 3, 4, 5. So we have 10 options for the first digit. And then we have 9 options, 8 options, 7 options, and we have 6 options, right? Now let me simplify this. So 6, 7, 8, 9, and 10. So this is 30,240. 30,240 passwords can be formed. Now for the second part, find the number of passwords that can be formed if the password has to contain at least one symbol, right? So at least one symbol. So let's do the first case with no symbol. At least one symbol means 1 symbol, 2 symbol, 3 symbol, or 4 symbols, because we have 4 symbols, right? So let's do the case with no symbols. When there are no symbols, it means all the 5-character password contain the letters. So 1, 2, 3, 4, 5, 6 letters we have. So 6, 5, 4, 3, and 2, right? So now we have 6, 5, 4, 3, 2. So 720 when we have no symbols. Right. And total passwords we can make are 30,240. So at least one symbol, or from the total 30,240 we have to subtract with no symbol, right? 30,240 subtract answer, which is 29,520, right? Now for part 3, find the number of passwords that can be formed if the password has to start with 2 letters and ends with 2 symbols. It's a 5-character password, 1, 2, 3, 4, and 5. So it should start with 2 letters. So the letters are 6 letters. So we have 6 and 5, right? And it should end with 2 symbols. Symbols are 4. So 4 and 3, right? Now for the middle one, let's say I used A and B. I use star and hash. So 1, 2, 3, 4, 5, 6. 6 options are left for the middle one, right? Okay, now let me calculate 6, 5, 6, 3, and 4. So this is 2160. All right. Now for part B, a team of 8 people is to be chosen from, it should be 8. 5 doctors, 4 teachers, and 6 police officers. Find how many possible teams have the same number of doctors as teachers, right? Okay, so if I can say D for doctor, D for teacher, and P for police officer, right? Okay, so if I can take 0 doctor, 0 teacher, so the police officers should be 8, right? So which is not possible because police officers are 6. So this is not possible because total should be, the team member should be 8, right? The next combination, because teachers and the police officer, the doctors and teachers should be same in number, right? So doctor is 1, teacher is 1, and 1 plus 1 would be 2, and we have 6 police officers, so the total would be 8. So this is possible. If doctors are 2, teacher is 2, the police officers would be 4 to make 8. Doctors are 3, the police officers should be 2, right? The doctor is 4 and teacher can be 4, so the police officers should be 0. So these 4 possible combinations we can make, right? Okay, so how can I write this? So this should be from doctors are 5, right? So we can say 5C1 times, we have teachers 4C1 times 6C6, right? And here 5C2, 4C2, and 6C4, right? And 5C3, 4C3, and 6C2. And here we have 5C4 times 4C4 and 6C0. Right, now let me calculate this. 5C1 times 4C1 times 6C6. This is 20. Okay, the next is 6C4 and 4C2 and 5C2. So this is 900. Okay, and we have 4C2, 6C2, 4C3, and 5C3. Right, so this is 600. And next we have 6C0, 4C4, and 5C4. This is 5. Right, so the total number of combinations we can make are, we have 20 plus 600 plus 900 plus 5. So this should be 1525 possible combinations. Question number 6. The polynomial q of x is given by part A. Find the x coordinates of the stationary points on the curve y equals to q of x. So x coordinates of the stationary point. For stationary point, we have to put y prime equals to 0. So the y prime is basically q prime of x. We have to solve, right? Minus 1 by 3 stays the same. Okay, now we have to use the product rule over here. The first function is as it is. The derivative of the second function, the power rule. Okay, and plus the second function is as it is, and the derivative of first function is 2, right? Now we can say minus 1 by 3, this is in bracket. Simplify, we have 2 into 2x plus minus 1 and x plus 3 plus 2 into x plus 3. So as you can see, 2 into x plus 3 is common. So minus 1 by 3, let's say 2 and x plus 3 common. So we are left with 2x minus 1, right, and plus 1. Okay. Now this is q prime of x, the derivative. Now we have to put this equals to 0 to solve for the stationary points. Now for stationary points, we can say y prime of x should be equals to 0, or q prime of x should be equals to 0, right? So minus 1 by 3, 2 times by 2, x plus 3 and 2x minus 1 plus 1, this should be equals to 0. I made a blunder, sorry. This is square, I messed up. Okay, so this we are taking 2 common and x plus 3. 2 and x plus 3, we are left with 2x minus 1. And over here we have not this, we are left with x plus 3. Right. So when I substitute this equals to 0, so 2 over negative 3 and x plus 3 is common. 2x plus x and plus 3 in the bracket. This is equals to 0, right? So negative 2 by 3 into x plus 3 and into 3x plus 3. This is equals to 0. It's 2x minus 1. Okay, so this should be x and this should be 2, sorry. Okay, when it is equals to 0, it means minus 2 by 3 is not equals to 0. X plus 3 is equals to 0, and the x coordinate of the stationary point is negative 3, and 3x plus 2 is equals to 0, and another x coordinate is negative 2 by 3. So these are the two x coordinates of the stationary point, which is negative 3 and negative 2 by 3, right? Okay, now moving to part B, on the axis sketch the graph of the function stating the intercepts with the coordinate axis. Okay, so it's a cubic polynomial. As you can see, we have minus 1 by 3, 2x minus 1 and x plus 3. So we have two zeros here, which is negative 3 and 1 by 2. This negative 3 is of order 2 and 1 by 2 is of order 1, right? So negative 3 x-intercept, let me open this over here. 1, 2, 3, minus 1, minus 2, and minus 3. Negative 3 is over here. This is the x-intercept of order 2, and 0.5 is the x-intercept of order 1, 1 by 2. Right. Okay, now let me state the y-intercept as well when x should be equals to 0. So for y-intercept, put x equals to 0, so we can say y is equals to minus 1 by 3 into minus 1 and into 3 square. So negative and negative should be positive. This 3 is 3, we cancel, so we are just left with 3. So the y-intercept is 3. So 1, 2, and 3 over here. This is the y-intercept, right? This is of order 2 and this is of order 1, right? Okay, now it is a cubic polynomial, so it means the graph extends from first to third or second to fourth quadrant. Since the leading coefficient is negative, so it means the graph extension is from second to fourth quadrant, right? So let me sketch this. So from second to fourth quadrant for negative leading coefficient, which is minus 1 by 3, right? So this is of order 2. It should be a parabola. This is the second quadrant. Moving to the x and y intercept. Sorry. Okay. Now let me connect in the fourth quadrant, second to fourth, right? Okay. This is the sketch. This is how the sketch looks like. Now for part C, find the values of k such that q of x equals to k has exactly one solution. Q of x is minus 1 by 3 into 2x minus 1 and x plus 3 square is equals to k. This has exactly one solution, right? So let me visualize the situation when it has exactly one solution. So look at the sketch when it has exactly one solution. So it has exactly one solution when the value of k is more than, this is, let's say, the vertex or the turning point. So not the vertex, we can say this is a turning point, right? So when the value of k is more than the turning point, right? So the turning points are basically the stationary point, and we got the two stationary points from part A, the 2x coordinates of the stationary point, which is -3 and -2/3. So let me solve for the y coordinates of the turning points, right? So turning points, or we can say the stationary points, the x coordinates are -3. Let me solve for x equals to -3. What is the y? So q of x, sorry, basically q of x equals to -1/3, 2 into -3, -1 and -3 and +3. This should be equals to, this is 0, so whole thing should be equals to 0. So the first turning point is -3 and 0, so this is done. X is -3 and y is 0, right? Now let me solve for the second turning point when the turning point is x is equals to -2/3. What is the y? Right, so q of x is equals to -1/3 into 2 into -2/3 -1 and -2/3 plus 3 whole square, right? Now let me simplify. -1/3, this is -4/3 and -1, -7/3, -2/3 and +3 and its square. This is 49/9, right? And times by -7/3 and times by -1/3. So this is 348/81. 348/81. In terms of decimal is 4.23, right? 4.2 and 3. This is the other turning point. And what is 2/3? 2/3 is 0.67, right? Okay, so 0.67, the other turning point we can say is 0.67 and 4.23 is other turning point. If we look at the sketch, x is 0.67 and y is, sorry, it's -0.67 and 4.23. So let's say this is another turning point. If I explain this situation clearly, we have, here I do this again. So this is a turning point. X is -0.67 and y is 4.3. So the turning point is -0.7 and 4.2. Right, this is a turning point. Now we have to solve for k when this has only one solution. So this curve has only one solution. So as you can see, when y equals to k, this straight line, it has this point, it has two solutions, 4.2. When the value is more than 4.2, it has only one solution. This line should be extended. So it has only one solution. We can extend this line, right? So as you can see, more than 4.2, it has only one solution, right? All those points, it has three solutions, right? So we can say your sketch has exactly one solution when the k value is more than 4.23, or we can say when k is more than the y coordinate of vertex, which is 348/81. Right. Question number 7, solve the equation, give your answer in exact form, right? So this is 6x power 1/3 minus 2 over x power 1/3 to make the positive exponent, and -1 equals to 0, right? Let me take multiplying throughout the equation by x power 1/3, multiplying and dividing basically. So 6x power 1/3, its whole square, minus 2 minus x power 1/3, this is equals to 0. Rearrange it. 6x power 2 by 3 minus x power 1 by 3 minus 2 equals to 0. Now this looks like a quadratic equation. So let me suppose, we are doing a supposition. Let m should be equals to x power 1 by 3, right? So when m is equals to x power 1 by 3, so this is 6m square minus m minus 2 equals to 0. So it's a quadratic equation in a variable m. Now 6 times 2 would be 12, 4 times 3 is 12, and 3 minus 4 is minus m. So 6m square plus 3m minus 4m minus 2 equals to 0. Let me take 3m common. We have 6, 3 times 2 is 6, 2m plus 1, and negative 2 is common, 2m plus 1 equals to 0. So the factors are 3m minus 2 into 2m plus 1 equals to 0, right? So here m is equals to 2 by 3 and m is equals to minus 1 by 2, right? So we have two values for them. Let me solve the equation in x because we have a question in x. Okay, so put it back. So x power 1 by 3 is equals to 2 by 3 and x power 1 by 3 is equals to minus 1 by 2. Let me solve for x. So now taking cube on both sides. So x should be equals to 2 by 3 cube and x is equals to minus 1 by 2 cube. So here x is equals to 8 over 27 and x is equals to 1 by 8, right? So these are the two exact roots. Question number 8. The first three terms in descending power of x in the expansion of this can be written in the form. This is the form where n, a, b, and c are integers. Find the value of n, a, b, and c, right? So we have to write down the first three terms, right? So the first term would be 2x squared, its whole power is n, right? And this term is equals to 256 x exponent 16, right? So from here we can easily solve for n, right? So we can say we have 2 exponent is n and x exponent is 2n. This is equals to 256 x exponent 16, right? We can equate when both the x exponents are same, right? So here we can say the 2n should be equals to 16. 2n equals to 16. So n should be equals to 16 by 2, which is equals to 8. So we have solved for n. So n value is 8. Right? Okay, now the next term. Here n is 8. Okay, so the second term is ax 13, right? So we can equate the second term. Okay, so this should be 8c1 2x square, its power would be 7 and minus 1 over 4x. This is the second term and this should be equals to ax 13, right? We have to solve for a. So what is 8c1? 8c1 is 8, right? So this is 8, this is 2 exponent 7, this is x exponent 14, this is minus 1 by 4, and x, this should be equals to ax exponent 13, right? We can equate the exponents. So x is cancelled with 14, it would be 13. So x exponent 13, x exponent 13, we can equate it. And what is left? 2 exponent 7, 128 times by 8 is 1024. 1024 and times minus 1 by 4. This should be equals to a. Times negative 1 divided by 4. So minus 256 is the a value. Right, we got the A. Now the next is B and C. Now the third term, let me compare the third term. So the third term is 8C2, 2x square, its power is 6, and minus 1 over 4x, its power would be 2. This is BXC, right? So 8C2 is 28. 2 exponent 6 is 64. Here x is 12. 1 over 4 square is 16, and x square, this is bx exponent c. First we have to solve for the c to comparing the exponent. So here we can cancel x square with x square and we are left with 10. So from easily get x exponent 10, so x exponent c, so c would be 10. By comparing, the c value is 10, right? And the b value we have is 28 times 64 and divided by 16 is 112. B is 112, right? So N, A, B and C all are integers. Question number 9, given that y equals to this, find dy by dx can be written. Show that dy by dx can be written in this form where a and b are integers, right? So we have to differentiate this basically. So let me solve for dy over dx, right? So here we have to apply the quotient rule, right? So first we have to write down the denominator function and the derivative of numerator function. So its derivative would be power rule we have to apply, which is 1 by 3. It's power rule, base, power minus 1. So 1 by 3 minus 1, and the derivative of base function is just 5. Minus the numerator function is as it is. And the derivative of denominator function is again the power rule, power, the base function, and the power minus 1. And the derivative of base function is just 1. X derivative is 1, right? And this should be divided with the square of the denominator function, right? Now let me simplify to get that form. So dy by dx, this should be equals to, we have 5 by 3 is outside, x minus 1 whole square, and 1 by 3 minus 1 minus 2 by 3, right? So 5x plus 2 minus 2 by 3 minus, and 2 is outside over here. We have x minus 1 and 5x plus 2, 1 by 3, and this whole divides with the denominator function, power should be 4, right? X minus 1, its power is 4. Okay, so as you can see, we have to make this form. So it means x minus 1, its power should be 3, and 5x plus 2, its power should be 2 by 3, right? Okay, for this simplification, dy over dx, this should be equals to 5 over 3 x minus 1 square over 5x plus 2, power is 2 by 3, minus 2 into x minus 1, 5x plus 2, power is 1 by 3, divides x minus 1, power would be 4, right? So here dy over dx, this should be equals to, let me take the LCM in the numerator. Okay, so we have 5 x minus 1 square, right? So let me take the LCM with 3 and 5x plus 2, its power 2 by 3, all right? Okay, so we have 2 x minus 1, 5x plus 2, its power is 1 by 3, right? So this function denominator is 3 and 5x plus 2, power is 2 by 3. Let me make this denominator the same. Its denominator is just 1, right? So we have to multiply and divide by 3. 5x plus 2. Its power is 2 by 3 over 3. 5x plus 2. Its power is 2 by 3, right? Okay. The denominator stays the same, which is x minus 1 power 4, right? Now the further simplification, dy over dx is equals to 5x minus 1 square minus 2 times 3 would be 6, x minus 1, and 1 by 3 and 2 by 3. 1 by 3 plus 2 by 3, this should be equals to 1, right? So 5x plus 2, its power should be 1. And this divides with 3. 5x plus 2, its power is 2 by 3, and x minus 1 power is 4, right? Now as you can see, we have the denominator 3. 5x plus 2 power is 2 by 3, x minus 1 power should be 3, because we can take x minus 1 common and cancel with the denominator. So x minus 1 is common. We are left with 5 into x minus 1 minus 6 into 5x plus 2, right? Let's cancel this out with the common factors of denominator. 3, 5x plus 2 power is 2 by 3, and x minus 1 power should be 4. So this is cancelled with power 3, the denominator we got. Now let me simplify the numerator. Dy over dx, this should be equals to 5x minus 5 minus 30x minus 12 out of 3 into x minus 1 cube and 5x plus 2 power is 2 by 3. Okay, so 5 minus 30, from 30 take away 5 is minus 25, and 12 and 5, 12, 13, 14, 15, 16, 17, negative of 17, this is x minus 17 over 3 into x minus 1 cube and 5x plus 2 power is 2 by 3, right? Now what is a and what is b? It should be in this form. Negative sign should be common. Okay, let's do one more step. So dy over dx is equals to negative ax plus b. So a is 25 and b is 17. Negative 25 and negative 17 basically. 3 into x minus 1 cube, 5x plus 2, power is 2 by 3, right? Question number 10. In this question, all the lengths are in centimeters and all angles are in radians, right? The diagram shows the sector OAB. This is a sector of a circle with center O and radius is 20. So OA is 20 and OB is also 20. Right. The perimeter of this sector is 65. The perimeter we have given, this is 65, right? So the perimeter of a sector is 65, and this should be equals to OA plus OB plus AB, right? So 65 is equals to OA is 20, OB is 20, AB is the arc length, which is radius times theta in terms of radian, right? Radius is 20 and theta is, keep the theta as it is because we don't know the theta. Okay, so now let me solve. 65 take away 40 and divided by 20, this is theta. 65 minus 40 divides 20, which is 1.25 or 5 by 4. 5 by 4 or 1.25 radians. Right. The next part of the question says the line CA and CB are both tangents to the circle at points A and B. So it means they are tangent to the circle at the same point. So it means CA and CB have same length. So the triangle ABC is an isosceles triangle and AC and ACB same. The angle AOB is equals to theta. Find the area of the shaded region, right? We have to find that area, okay? So for this, let me calculate the area of both triangle. This is the triangle AOB and ABC. We have two triangles. Let me calculate the area of first triangle, the area of second triangle, right? And that would be the total area, right? And then from the total area we have to subtract the area of this sector. We will get the shaded one, right? So area of both triangle is the total area, and then subtracting the sector, because sector is not shaded, we will get the unshaded, the shaded one, right? Okay, so now let's work on area of both triangles. Let me start with the triangle. Area of triangle AOB, okay, which is half. Two sides are 20 and 20, and sine of 1.25 radians. Okay, it should be in radians. Sine 1.25 times 20 times 20 divided by 2. This is 100. 189.79. So 189.8 centimeter square is the area of this triangle, right? Now let me find the area of the triangle ABC. So but we don't know what is AC and what is CB, right? So first we have to find the sides. So if I consider the triangle ABO, this one, we have OA and OB. Let me solve for AB, and we have one angle as well. So let me apply law of cosine to solve for AB, right? Okay. Solving for AB, right? We are working on AB, so law of cosine, which is AB square is equals to the two sides 20 square plus 20 square minus 2 times of 20 into 20 into cos of 1.25 radians, right? Now solve it. Cos 1.25 times 20 times 20 times negative 2 times 20 square. No, it should be add, sorry. Cos 1.25 times 20 times 20 times negative 2. Add 20 square and add 20 square, and then square root of answer is 23.4. So here we can say AB is 23.4 centimeter, right? So this AB is 23.4, right? Now we have 20, 20, 23.4, and this angle is 1.25. As you can see, this angle is 90, the right angles, right? So let me solve for this angle. What is these two angles? Okay, so we have three sides and one angle. Let me apply law of sine over here, right, to solve for that angle A, right? So law of sine, it says sine A over its front side is 20 equals to sine of 125 and its front side is 23.4. 1.25, sorry, over 23.4, right? So let me solve for sine of A, which is 20 over 23.4, and times it by sine of 125, and then 1.25, sorry, and then doing its inverse to get A. So what is angle A? So 20 times sine 1.25 and divided by 23.4, doing sine inverse of answer is 0.94, or we can say 0.95 radians, right? So this is 0.95, right? Okay, and this is also 0.95 because this is an isosceles triangle. Two sides are same, two angles are same. So this whole angle is 90. So 90 is basically pi by 2 in radians, right? So what is that angle? These two angles. So from 90 we have to take away this. So we can say pi by 2, right? And subtract answer. You have 0.624. This is 0.625, you can say 0.62, 0.62, right? Okay, now we know the two angles of a triangle ABC. Let me find the third angle by adding all the three angles and put it equals to pi. So we can say from pi subtract 0.62 and subtract 0.62. This is 1.90. 1.90, right? Now for this triangle we have all the three angles and one side. Let me solve for the rest of the two sides because this is isosceles, so AC and CB is same. Okay, so applying law of sine here again. Law of sine we are applying on triangle ABC before we have applied on OAB, right? So here we can say AC, we can take the side AC over the angle B, sine 0.62. This is equals to 23.4 over sine of 1.90, the front angle, this side and this angle, right? Now let me calculate what is AC. 23.4 times sine of 0.62 divides sine 1.90, right? Sine 0.62 times 23.4 divided by sine 1.90, 14.36, 14.4 AC. AC and CB is 14.4 centimeter, right? So we got these sides are 14.4 and this is also 14.4, right? Let me apply the area of the triangle ABC. Solve, right? So area of triangle A, B and C. This is half. The two sides are 14.4 and 14.4 and the sine of angle between them is 1.90. Just got it. Okay, sine 1.90 times 14.4 times 14.4 and divided by 2, which is 98.11. So this is 98.1 centimeter square, right? So let me solve for area of the whole shape. Area of, we're working on full shape. We can say this look like a kite. A, C, B and O. A, C, B, O, which is the sum of two triangles, right? So the first we got is 189.8 and the other is 98.1. Right, 189.8 plus 98.1. This is 287.9 centimeter square, right? Now let me work on area of a sector. Area of sector of a circle which is OAB. area of a sector is, which is half radius square, and theta is 1.25. 1.25 times 20 times 20 divided by 2 is 250 centimeter square. From total area, subtract the sector area, we will get the shaded one, right? So here we can say shaded area would be, total is 287.9 minus 250. Okay, so 287.9 minus 250, this is 37.9, or we round it to 38 centimeter square. This is the shaded area. Now question number 11. In triangle OAB, O, A and B, OA, O to A is A, O to B, this is B, this O to B, this is B. The straight line XYZ is such that X, Y and Z, this is a straight line. O to X, OX, this is 4 by 5 of B. 4 by 5 of B. So XB is 1 by 5 of B. Right? AY is 1/3 of AB. AY is 1/3. And this is 2/3. This is 1/3 of AB. So solving for AB first. AB is A to B, AO and OB. A to O is minus A and plus B. So this is B minus A. And this is B minus A. Okay, AZ is mu A, where mu is a constant. A to Z. Right, this is mu times of A. And YZ, Y to Z, this is lambda times of XY, where lambda is a constant. Now for part A, we have to show that XY should be equal to this, right? So we have to solve for XY. X to Y is X to B and B to Y, right? XY equals to XB and BY. X to B is 1/5 of B and BY is negative 2 by 3 of B minus A. Right? Now simplify, we have 1 by 5 of B and minus 2 by 3 of B and plus 2 by 3 of A. Solving for the B coefficient, which is 1 by 5 and minus 2 by 3, minus 7 over 15. So 2 by 3A is as it is and minus 7 over 15B. And this is proved XY is equals to this. Now for part B, find YZ in terms of lambda A and B. YZ we have to find, right? Y to Z is lambda XY we have given, right? YZ, this is lambda of XY, and we got XY in the previous step, which is lambda times of 2 by 3A and minus 7 over 15B. Right, now for part C, find YZ in terms of mu AB. So YZ is equals to mu AB. Y to Z is Y to A and A to Z. Y to A, this would be negative 1/3 of B minus A, and this is mu of A, right? Now for part D, hence find the values of lambda and mu. So we have to equate the two YZ. YZ should be equals to YZ The first is lambda and 2a over 3 minus lambda 7 over 15b equals to minus 1 over 3b plus 1 over 3a and plus mu a. Right, now we have to equate a and b. Equating the coefficients of a, which are lambda 2 by 3 and equals to 1 by 3 plus mu. This is my first equation. It involves both, right? Equating the coefficient of b are minus lambda 7 over 15 and this would be equals to minus 1 over 3, right? So here we can solve for lambda. Minus is cancelled with minus, so lambda would be 1 over 3 times 15 over 7. So 3 times 5 is 15. So here lambda should be equals to 5 out of 7. So when lambda is 5 by 7, let me plug into the first equation. Mu should be equals to minus 1 over 3, shifting 1 over 3 on the other side, and plus 2 by 3 lambda. 5 by 7 is the lambda value. So mu should be equals to minus 1 by 3 plus 2 times 5 is 10 and 3 times 7 is 21. Okay, 10 over 21 and subtract 1 by 3. 1 by 7 is the mu. So mu value is 1 by 7 and lambda value is 5 by 7. Question number 12. Solve the equation for x is between 0 to 3 pi. Give your answer in terms of pi. Right. So cosecant is the reciprocal of sine. Right. So if I can take 3 by 4, this is equals to shifting cosecant is 1 over sine, so 3, and then divide that 4, and 1 over sine is over on the other side would be sine square of 2x over 3 and minus pi by 3. Now taking square root on both sides, so this should be sine of 2x over 3 minus pi by 3. This should be equals to plus minus square root of 3 over square root of 4, which is 2, right? So we have two cases with a positive one and with a negative one, right? So let me solve with the positive one and the negative one. So 2x over 3 minus pi by 3, this is square root of 3 by 2. And the other is sine of 2x over 3 minus pi by 3 is negative of square root of 3 by 2, right? Okay, so here we can say 2x over 3 minus pi by 3 is equals to sine inverse of square root of 3 by 2. It should be in radians, right? My calculator is in radians, so sine inverse square root of 3 divided by 2, pi by 3. So 2x over 3 minus pi by 3 is equals to pi by 3, right? Now let me use the cast rule and check sine is positive and negative in which quadrant, right? Let me draw the cast rule. Visualize the situation. So the cast rule CAST, it means all positive, sine positive, tangent positive, and cosine is positive, right? And the operations we can apply is x, and here we have pi minus x and pi plus x and 2 pi minus x, right? Now sine is positive in the first quadrant and in the second quadrant, and it is negative in the third and the fourth quadrant, so right? So first quadrant value we got, which is pi by 3, lies in the first quadrant. Now for the second quadrant, which is pi minus pi by 3, so we can say pi minus answer, which is 2 pi by 3, right? Which is 2 pi over 3. So these are the two solutions for the positive one. Now let me simplify for x values, right? So the first one is 2x over 3 minus pi by 3 equals to pi by 3. So 2x over 3 equals to pi by 3 and plus pi by 3. This is 2 pi over 3. So 2 by 3 is cancelled with 2 by 3, and from here we have x equals to pi. The first solution is pi, so we can take pi because the range is between 0 to 3 pi. So this belongs to the range, right? The second solution is 2x over 3 minus pi by 3. This is equals to 2 pi by 3. So 2x over 3, this should be equals to 2 pi by 3 and plus pi by 3. 2 by 3 plus 1 by 3 would be 3 by 3, which is just pi, which is pi. And from here we can say x is equals to 3 pi by 2, the reciprocal. This also belongs to the range. 3 by 2 is 1.5 pi. Yes, it belongs. Okay, now let me work on the second one with the negative case. So here we have 2x over 3 minus pi by 3. This is equals to sine inverse of square root of 3 by 2, and we got this pi by 3. This is my x. Now sine is negative in third and fourth quadrant. Now for the third quadrant, we can say 2x over 3 minus pi by 3. This should be equals to pi plus that x value. So pi plus pi by 3, 4 pi by 3. Let me simplify. 2x over 3, this is equals to 4 pi by 3 and plus pi by 3. Pi by 3, this is 5 pi by 3. So we can cancel the 3 and 5 by 2 pi is the answer. X is 5 by 2 pi. And 5 by 2 also belongs to the range, which is 2.5, right? Now for the fourth quadrant, we have 2x over 3 minus pi by 3. This should be equals to 2 pi minus that x value, 2 pi minus pi by 3. 2 pi minus pi by 3, 5 pi by 3. 2x over 3, this should be equals to 5 pi by 3 plus pi by 3. Okay, you add pi by 3, 2 pi. 2 is cancelled with 2, and x should be equals to 3 pi. And this belongs to the range because we have equality on 3 pi, right? So we can say all the solutions of x, let me write over here, x is equals to pi, 3 pi by 2, 5 pi by 2, and 3 pi. So these are the 4 solutions that belongs to the range, right? So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.